And then I'll start exactly at 11. Okay, I'm starting.
The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome to the January extra meeting for the DBA Fundamentals Virtual Chapter. Today's presentation is entitled Statistics Starters. It will be presented by Aaron Stellato. I'll be turning things over to Aaron in a few minutes, but I want to bring a few things to your attention first. First, I'd like to thank the Professional Association of SQL PASS for supporting the DBA Fundamentals chapter. The management at PASS truly work tirelessly to bring free training all over the world, and they do a great job. Free training the SQL community has is truly amazing. My name is Steve Cantrell, and I'm a chapter co-vice president of the DBA Fundamentals Virtual Chapter. On February the 4th, we're going to have Tara Jana, who's a SQL Premier Field Engineer in Australia with Microsoft. He's presenting a session called SQL Server 2014 Features Drill Down. You won't want to miss that. Okay, it's all housekeeping I can think of at the moment, so let's get started. Today we have Aaron Stellato presenting Statistics Starters. Aaron is a principal consultant with SQL Skills and lives in Cleveland, Ohio. Aaron's a SQL Server MVP and an active member of the SQL Server community. She's involved with Ohio North SQL Server Users Group and blogs at sqlskills.com/blogs/Aaron. You can find her on Twitter at Aaron Stellato. Over to you now, Aaron.
Thank you very much, Steve, and hopefully everyone can hear me okay. If you're having any issues, just feel free to use the questions box to let me know. And if you have questions as we go along, please feel free to ask them, and I will get to them as I have time. So Steve gave a pretty good introduction, but just a little bit of information for you guys to file away. I do work for SQL Skills, so I work with Paul and Kimberly and Glenn and Jonathan. And this is my blog, sqlskills.com/blog/Aaron, and my email address as well. If you have follow-up questions related to this session, please feel free to reach out. I also have some posts specific to statistics on my blog, but I'm always willing to write some more if I have some great questions, so feel free to share those. Steve mentioned I'm on Twitter, Aaron Stellato. Feel free to say hi. I'm a SQL Server MVP. I have courses out on Pluralsight. If you're not familiar with Pluralsight, it is recorded material that you can view at your convenience, and I've got a couple sessions out there, and we've got many sessions from the SQL Skills team specific to SQL Server out on Pluralsight. And you can just go to pluralsight.com to see those. And I volunteer for PASS. As Steve mentioned, I live in Cleveland, where it's a balmy 11 degrees here today. And we have our SQL Saturday coming up on February 8th. So if you're in the Cleveland area, definitely visit sqlsaturday.com and sign up for that. So a little bit about SQL Skills. This is our team and all of our handles for Twitter. We do our immersion events. We've got many of them coming up in Tampa in February. I cannot wait to go from 11 degrees to whatever warm weather it is in Tampa, Florida right now. Again, many of us have courses on Pluralsight, or we all do. And we do consulting. We provide remote DBA services, and we speak at conferences. And if you're not a SQL Skills insider, feel free to check out the link I've got here to become one. And that just means that you'll get an email from us about every other week, kind of just about what's going on with a little note from Paul, and then also a video that we've recorded with some tip. I just did one actually in yesterday's Insider on statistics, and it's not one that we're going to cover today. So if you want to get a little bit more detail beyond what we talk about today, feel free to check out the Insider video. Okay, so to get started, this is the abstract, which I'm not going to read to you because I'm assuming you're here because you've already read it and it's of interest to you. But this is a basic session. It's a starter session, which is where do stats exist? How do you find them? What are the options for statistics? Do they really matter? And we're just going to basically lay the foundation of the groundwork for making sure that we understand statistics. So let's get right to it. The first thing thing is, why do we even care? Why does it matter? Why, as a DBA, should you be concerned with statistics? And I'm going to start with an example because I think it's a great place to start. And we're going to start with a table called players. Now, I recognize that it is still football season, right? Super Bowl's in 2 weeks. And it's also still basketball season. And I'm much more interested in college basketball, but March Madness doesn't start for another month or so, right? So instead we're going to talk about baseball, which baseball's over, but as a reminder, pitchers and catchers report within the next 30 days. And if you're a Cleveland Indians fan, they report in 21 days, just so you know. So we have a players table, and we have a batting table. And let's say that we have a query that selects information from the players table and the batting table, and we join on player ID, where a player has played in more than 100 games and had more than 100 hits, and their last name is Williams. So when you write this query and you submit it to SQL Server, how is SQL Server going to get that data, right? How is it going to get the answer and list those people for you? Is it going to scan the entire players table first? Is it going to scan the batting table first? Is it going to use an index for players? Is it going to use an index that you have on batting? It's going to depend on what indexes you have, but it will also depend upon the statistics. Right? The statistics give the optimizer the information to say, well, this is where you want to go first because this is more unique, or this is where we want to start with our search. So statistics are vital because they tell the optimizer how it should go and get the data. They basically are one of the things that determine the query plan that SQL Server generates. So just to put this in pictures, I have a query. I submit it to the optimizer, and it has these decisions, right? What kind of, am I going to use an index to all? Am I going to seek the index or scan it? What kind of join am I going to do here? And then based on that and so many more things, right? There's actually a ton of other things that the optimizer considers that I'm not putting in here. We get a query plan. So let's talk about how statistics get created, because that's where we have to start, right? In order to give the optimizer statistic information, we have to have statistics. So let's talk about how they get created. So they exist over a column or a set of columns on a table or an indexed view. And for every index or indexed view, a statistic is created automatically. And I make note of that because I think that sometimes in the beginning, people get confused about indexes and statistics. Because when you create an index, you get a statistic, and it has the exact same name as the index. But they're two different entities, right? An index is a subset, typically, of your table, a subset of columns, stored in an ordered list. And so that actually persists, right, on disk. A statistic is information about the distribution of data in there, and it's stored in a statistics blob, but it's a separate entity. So I want to make a note here that an index and its statistic are two different entities, but they have the same name. You can also get a statistic for one individual column, and this can occur automatically, which we'll look at, or it can occur manually. You can have a statistic across multiple columns, which is not an index, just a standalone statistic across multiple columns. That gets created manually only. Those do not get automatically created. And then you can have a filtered statistic, and we'll look at that again, and those only get created manually as well. And I have a note here in the bottom for the best way to look at statistics for a table, and it's using the sys.stats catalog view. And we'll take a look at how to do this as well. So let's go. We're going to go right into a demo, because I like demos and I like seeing things. I think it makes a lot more sense when we can actually look at something. So I've got a long detailed demo here with lots of back and forth. And one thing that I did not do, which is a complete flaw on my part, oh my goodness, is I did not start up Zoom-It. So let me do that very quickly here. You would think I would know better. But just in case I need it, let's make sure that we've got it running. So we're going to work with a baseball data database. And I just reloaded this data. Actually, it's current through 2013. It's free. It's available online from a guy named Sean Lehman, who puts this together every year. And it'll be available for you to download from the SQL Skills site as well. Let's go ahead and use that database. And the first thing that I'm going to do is I'm going to take a table in here that I already have called players. and I'm going to create a new table called player info that's not going to have any rows in it. Okay, so this has nothing in it. So now I said that sys.stats is the easiest way to see what statistics exist. So we're going to run that query against sys.stats for our player info table that we just created. And you can see, right, we have no statistics which exist. All right, let's create a clustered index on our table. And we're going to create it on the layman ID, which is the unique ID for this table. So we've created our index. And now let's use DBCC show statistics. So this is the command that you use to look at the actual information about the statistic. So sys.stats tells you what statistics exist. But if you want to dig into the information within the statistic, you're going to use DBCC show statistics. And the first thing that you put in here is the table name, and then you have the statistic name. And again, our clustered index is named CI_PlayerInfo_ID. Our statistic has the same name. So let's look at our statistics. And we have three sets of output here. We have the header, we have the density vector, which is the second. Let me make this a little bit better here. Here's our header information. Here is our density vector. And down here is our histogram. But we have nothing here, right? We have no information. We've created the index. We don't have any data in the table. So there's nothing that shows up here within our statistics. Now let's push some data into the table. So I'm going to take all of the rows that are in my players table, and I'm just going to push them into my new player info table. All right, so we've added a whopping 16,000 rows. And now we're going to check our statistic again. So we're going to run show statistics again for the clustered index. And we have nothing here. Right, now why don't we have anything here? I just put a bunch of rows in the table. Why isn't the information updated? It's not in this case because we haven't done anything to query that data, so there's no automatic update that we're going to invoke. And we haven't updated the statistic in any way. Right? And I can confirm that this index exists. If I look at sysindexes and I join over to sysobject and I look for player info, I can see that my index exists, right? Index ID of 1 because it's a clustered index. And my index level of 0 is my leaf level. There's my 16,000 rows. And this is my root, right? One page with 452 rows on it. Okay. Now let's go ahead and create a non-clustered index. So we created our clustered index, and then we added data. Now we're going to create a non-clustered index, and there's already data in the table. And so now if we look at our statistics for this index, we can see that we have information, right? And this is because we created that index after data already existed. So when it created the index, it generated the statistic at the same time based on the data that was in the table. So if we look at this in a little bit more detail, if we look at our histogram, right, just a review of what's in here. This is the name of the statistic. This tells us when it was last updated. So we just updated it just now. This tells you the number of rows that were in the table at the time of the update. So that may change in that there may no longer be 16,564 rows in it when I look at the statistic because data may have changed. It's the number of rows in the table at the time that the sample was taken. And this is how many rows it sampled, right? And these two match, which tells me that it was 100% sample. I can then see how many steps that I have in the histogram. And I'm not going to worry about the recipes too much right now. I just want you to focus on these first few columns because this is where we start, right? We look to see when was the statistic last updated and what was the sample. Down here we have our density vector. This tells us how unique our information is, and I'll come back to this later on. And down here at the bottom, this is our histogram, right? This is our distribution of data. And if we have time, I'll go into the histogram a little bit later. So let's hop out of here. And while I'm chatting here, I'm going to pull the questions off to the side so that I can see those as I'm going along. So I'm just going to hop in really quick and answer this. Is everything going to be provided afterwards? Is the slide deck or the scripts, is the database going to be available? Yeah, they'll all be available for you to download, and Steve will share that information after the meeting. Okay, so we've got our statistics here. Now let's rerun our original stats query. And now we see that for this table, we have two statistics. We have one for our clustered index, one for our non-clustered index. And again, the statistic is the same, has the same name as the index. Actually, just for fun, let me just do this. I'm not typing really in a demo. I'm just changing things around. Right, so here we go. Here's our index information down here, and this is our statistic information. Same name, but two very different entities. Okay, so now what I want to do is I want to look to see if the Auto Create Statistics option is enabled. And this is a database option, right? If we come in here to our database and we look at our properties, we can look at this option this way. I can go to my Options tab, and what I am talking about here is this option in here, my Auto Update Statistics, and I also have an Auto Create Statistics option up there. So these are a couple options at the database level, specific to each database, related to statistics. And the first one I want to talk about is Auto Create Statistics. Now the old way to look at this is the ST_DB option. This does not work in 2012. You get a good old error if this happens. What we want to do instead is query sys.databases. So let's run this, and we can see that Auto Create Statistics is enabled. And if it were not enabled, I can do an alter database set Auto Create Statistics on. Now, you know already, based on this query back here, that at present I have two statistics on this table, right? One for my clustered index, one for my non-clustered index. Now what I'm going to do is I'm going to select against a column. I'm going to select against the column NameNick, which is for nickname. So I'm just going to run this query, and I get 2,789 rows. And now I'm going to rerun my stats query. And lo and behold, I have a new statistic. So this statistic was automatically created by SQL Server because I have that Auto Create Statistic option enabled, and it also gets created because I have no index which feeds on this NameNick column. So there's no statistic that already exists. Therefore, when I run this query, SQL Server says, well, I don't have any information about this column. I'm going to go ahead and create a statistic for it. So anytime you see a statistic that starts with the _WA sys, you know that that's a statistic that's automatically created. And you can query sys.stat to confirm this with the auto-created column as well. Now, I can manually create these column statistics, and I can give them any name I want. Now, hopefully, I wouldn't follow the same naming convention and name it, W_WA. I would just call it, I created, just for fun. Let's make it fun. So I can create this statistic, and then if I look at my statistics again for the table from sys.stat, I can now see this column. And it says, I have output that says, okay, no, it wasn't automatically created. It was user created. Now, I've got an interesting question here that I'm going to take a moment to answer, which is there a way to find out which automatically created statistics are used the most? It's an interesting question. It would be great to know in general, I think, what statistics are used the most. And that's not easy to do. In fact, I think that in order to do it, it would be rather complicated, and you'd have to be minding the cache, and I'd have to really think through how it could be done. But there's no dynamic management view that tracks how often a statistic is used like there is for indexes. Okay? Next question about auto-create statistics is, if you enable auto-create statistics on a fairly large table, would it take a long time to generate? Well, it depends. If it's a large table, it's probably not going to generate with 100% sample. It's probably going to generate with a default sample, which is usually somewhere less than 10%. So it's going to sample, 10% of the table, and it's going to create the statistic that way. So it really depends on how big that table is. I don't know what you mean when you say it's a big table. And it's also going to depend on your hardware, right? How fast can it read those pages off of disk to generate the statistic? But there have been cases where when you have that auto update or the auto create statistic option enabled, that there can be a delay because that statistic has to get updated. So it's not out of the realm of possibility. Hang on, I'm reading some questions here. I'm going back to make sure that I haven't missed anything. So there was a question, is it safe to say that statistics are only created as data is accessed or modified? It is safe to say that a statistic will be created if you query a column and that column is not the leading column in an index. That's how an automatic statistic gets created. Okay, so the statistic isn't going to, and it could be, that could be part of a select statement or possibly part of an update statement or delete statement. Okay. Okay, that was a weird message that I just got. Everyone, I assume, can hear me okay, so I'm going to keep going. Let's see. I created a clustered index and a non-clustered index. Why is it showing up as 0 in user created? That's a good question. This is going to be, this user created is going to be specific to column statistics. It's not going to be specific to index statistics. So if you see auto created and user created as 0, you can probably assume that it's an index statistic. I'd have to make sure on that one. Okay, so I'm going to keep going on. I'm going to go ahead and look at a filtered statistic. So this is new functionality that was added in SQL Server 2008. You can create filtered indexes. You can also create separately filtered statistics. So a filtered statistic says, okay, I'm going to create this statistic on this table on the column of final game, and then you put a where clause in. I'm filtering out some data. In this case, I'm including where final game is null, because what I'm going to do is I'm creating a statistic that is basically listing only information for active players. So I can create that statistic, and if I rerun my stats query here, I have this new statistic that I created. I can see it's user created, and now I also added a filter column, so I can see that this is a filtered statistic, and I can see what the filter is. Okay. Now, I want to point out something about sys.stats. There are other ways to view this information, but I really think sys.stats is the best way, and let me show you why. This sys.stats was added in SQL Server 2005. The old way to look at this information, which is deprecated, but you can still do it, but it's deprecated, which means gone out of style, is SPHelp stats. And when you run it with just the default syntax, you hopefully notice that it only gives you column level statistics. If you wanted index statistics too, you needed to include all. And I like this because it includes the statistics keys, right? By default, we don't get that from sys.stats. But I wrote a fun query, not a pretty query, but a fun query, which does give us that information. So this is kind of the beast. It goes against sys.stats and sys.objects and sys.schemas and sys.indexes. And it will give us all the information that I think we really want right here. So we've got the player, or excuse me, the table, which is player info. If it is an index statistic, it gives us the index ID, very useful. Statistic name, the columns that are in the statistic, I like seeing that. Whether it was auto-created, user-created, filtered, the filter definition, and whether it's temporary statistic or not. Now, I can go one step further, which is when I talk about statistics, it's nice to know what statistics exist, right, and what columns exist in there. But what's also really cool to know is when they were last updated. And if you remember, we looked at that when we ran DBCC show statistics. But I have to run DBC show statistics for each statistic. I have to roll through that. And that's not an easy thing to do with code. You can do it with code, but in SQL Server 2008 R2 SP2 and higher, and in 2012 SP1 and higher, they added this lovely dynamic management function, which is DMDB stats property. So I took my original query against sys.stats, and I added an outer apply here against stats properties. And let me show you what this gives us. So in addition to everything I had before, table, index ID, statistic, columns, and all of that, look what I get over here. I get information from the histogram. It's just a select set. It's not everything. But from right here, I can see when stats were last updated. I can see how many rows were in the table at the time of the update, how many rows were sampled, how many rows are not filtered. And then we're going to come back to row modifications along with histogram steps. So if you're running 2008 R2 SP2 or 2012 SP1, this query will work for you. If you're on an older version, you're still going to have to use show statistics. So let's take a couple looks. Let's take a look at what other questions I've got coming in. And by the way, this is meant to be kind of a back and forth session because it's a starter session. So I've got a lot of basic information I'm presenting, but I anticipate questions. So let's see. Do statistics consume a lot of space? That's a great question, and it's actually on my list of blogs to write. It's a statistics blog. It's not a significant amount of space. It's not as much as an index would consume, definitely. But it is stored in a table, and it does have to be read from disk into memory, just like anything else. So the size of the statistic is really going to depend upon the columns in the key and how wide those columns are. That's going to affect some of the statistics information. So I don't have a definitive answer. The more statistics you have, obviously the more space is going to be needed. But I don't have a good number in terms of bytes or kilobytes or megs. But it's definitely not the same as an index. How do you determine whether it would be wise to, this is a question, I should preface that question. How do you determine whether it's wise to just generate statistics manually using SPCreate statistics versus auto-generate statistics? My recommendation is that you leave both of these options enabled, right? So if we come back to our database options and we look here at our statistics options, these two right here, auto-create statistics and auto-update statistics, I recommend leaving those both set to true by default. I don't tend to recommend running the option to create statistics with the SPCreate statistics. Let SQL Server create them when it needs to create them. Let me look at another question. When a statistic is created as part of an index and a query for the same column, how does the optimizer use the information? I'm interested in cleaning up stale, unused statistics like deleting unused indexes. So this is a good question. So let's walk through this scenario. I went ahead and I ran this query, right? I ran this query where I selected against name.nick, and then when that happened, it created this user statistics for me. But what would happen if I went ahead, this is where we get tricky, right? Because I'm typing on the fly in a demo, which you're never supposed to do. But we're going to go ahead now and do this. I'm going to create this index here. Now when I rerun my stats query again, I have this, right? I now have a non-clustered index on my nickname column. And because of that, I have a statistic for it. So now all of a sudden, I have two statistics for the same column. And this is redundant. And SQL Server isn't going to go and clean that up automatically. And SQL Server isn't necessarily going to always use the same statistic over the other. And these statistics are not always necessarily going to be kept in sync. So I do have code. It was in one of our insider emails to find duplicate statistics and clean them up. But again, in terms of finding statistics that are unused, that's a lot trickier because SQL Server doesn't track statistic use. Okay. I'm reading some questions. Some of these are getting into updates, which I'm going to get to in a second. There's a question about where statistics are stored. They're stored in the system table. All right. Another question. This is a good one. I've never tested this before. Does encrypting a column in any way affect or prevent statistics from working? Not to my knowledge. I've never tested it. That would be a good one to try. Maybe I will write a blog post on that. That's a good one. Thank you. Okay, I'm going to flip back to the slide. Oh, this is the one. This is the slide deck that I created in the event that we had a problem. Let's go and open the right slide deck. See, last time, some of you may remember, last time I gave this presentation, I had some scary moments where my demos just sadly went away completely. And actually, we lost the connection entirely, and we don't know why. So we had a lot of fear about having that problem today. So I have another deck created with screenshots just in case things go crazy. But knock on wood, we're doing well. So we understand now how statistics are created, right? Multiple ways that can occur. When you create an index or an index view, they get created. When you have auto-update statistics enabled, they will get created. You can create them manually on a column, on multiple columns, or as a filtered statistic. Now let's talk about when they get updated. And updating statistics is important because that updated information, or the information about statistics, is provided to the optimizer. And if that information is inaccurate or out of date, then you're providing bad data to the optimizer. And it can make a poor decision because it doesn't have a good understanding of what your data looks like. So first of all, stats are going to be updated as part of an index rebuild. So it only updates index statistics. But when I rebuild one index, it updates the statistic for that index with 100% sample. If I rebuild the indexes for all tables, if I rebuild all indexes on a table, it will update the statistics for those indexes, but it won't update the column statistics. I can update statistics manually. I can use the update statistics command, or I could use something called SP update stats. Now, update statistics is going to be specific to a table or to a statistic, whereas SP update stats is for the entire database. And I'm going to talk about why I don't love that option and show you. Now, statistics can also be updated automatically, which I've mentioned already. And this happens when there is a certain number of rows that change. And it's 20% of the rows in the table plus 500. That's kind of the general rule of thumb. Now, there's an exception here in trace flag 2371, which I'm not going to get into, but that lowers the threshold for when the auto update occurs. It isn't typically a full scan. Once your table is more than 8 meg, SQL Server doesn't do a full scan unless you ask for it. It starts to go down in the percentage of pages that it samples. The automatic update can be immediate, which is by default, or it can occur asynchronously, and that's a separate setting that you would configure for your database. And the automatic update occurs whether it's an index statistic, a column statistic, or a filtered statistic. It doesn't matter at that point. An important note that I have here is to remember that when you update statistics, your queries will recompile. And in general, this is a good thing, right? Because you're updating statistics, presumably because the data in the table or the column has changed, and you want to provide updated information to the optimizer. So when you update that statistic, the optimizer says, well, I got a new statistic. This old information isn't valid, so any query that used that statistic, I'm going to flush out of cache, and I'm going to generate a new plan the next time that you run that query based on these new updated statistics. Okay? So typically that's a good thing. There's a star here. There's an asterisk at the end because there's an exception. And the exception is that if you have the option of auto-update statistics disabled, if you have that option off, then when you update stats manually as part of an index rebuild, as part of a job, your stats will get updated, but the query plans won't get invalidated. So it's a tiny exception to the rule, and I have a blog post about that. So let's go ahead and take a look at what this looks like in reality. If I can get back to my management studio here. Let's see. Nope, not going to worry about that. I've got some questions. Hang on one second. There's a question about update date, and it says, would the last update date of a statistic be a good indicator that the statistic isn't used? So let me just look at this for a second. Let's look at it for this so that we're all looking at the same thing to make sure I'm in the right database. The question is, can we assume that this column tells us whether or not the statistic is being used? Not necessarily, because I could disable auto-update statistics in my database. And I could never rebuild indexes, and I could never update statistics. And so this statistic would never get updated, but it might still be being used. So you can't rely on the updated date to tell you if a statistic is being used, because the flip side of that is that I could be updating statistics every day for some crazy reason with 100% sample on all my databases, but the statistic might not be used. So even though I'm updating it, the stat isn't used. So updated date isn't really a good way to determine if a stat is being used. Okay. I got a couple questions that I'm going to come to. So if I don't answer them in this, I will come back to answer them. Okay, so now we're on my second demo. Again, we're using our database, and we're going to make sure that auto create statistics is on and auto update statistics is on. Remember, these are enabled by default whenever you create a new database, and I recommend leaving them as such. I'm going to drop the table that we were playing with. We're going to start over, and we're going to keep using the same table, but I'm starting from scratch. So we're going to create player info based off of players, and now I'm going to create two of my indexes up front. I'm going to create my unique clustered index first, and I'm going to create my non-clustered index, which is on last name and first name. And these names are intuitive, right? But they read funny. But this is the default for the database, and I just left it as is. Again, if you get a copy of the database, you should feel free to go nuts and rename it. I'm going to create a statistic on birth state on that column. And I'm going to create a filtered statistic, again, just like I did before, on final gain. And now I'm going to push a whole bunch of data in the table, but I'm only pushing 12,000 rows in here. We get 11,990. And at this point, right, remember, I created my indexes. I created my statistics. I've pushed in all of this data. Now, I haven't done anything else. If I look at my statistics for all four statistics, my clustered index, my non-clustered, my column, and my filtered, right, at this point, there's no statistics information. So let's look closely here at how things get updated. The first thing I'm going to do is I'm going to alter my clustered index, and I'm going to rebuild it, just my clustered index. So let's do that. And now I'm going to look at the statistics for all four of those again. And now I see that my clustered index statistic has been updated, right? But these other three haven't. So when I specifically just rebuild one index, that statistic is updated and that's it. Now let's reorganize my non-clustered. So I'm not rebuilding this index, I'm reorganizing this index. So if you're playing along at home, what do you think is going to happen? Nothing. Right? That non-clustered index, nothing happens to it when I reorganize. The statistic doesn't get touched. So if you are only reorganizing your indexes and you're not rebuilding them, then you do want to update your statistics after you reorg. So that was a question that someone had. Good question. Now, if I rebuild all my indexes on this table, let's just say I blindly go and I'm just rebuilding every index on my table. What do I get? I just get the index statistics updated, right? So those are updated, but nothing happened down. Nothing happens down here with my column statistics. Only my index stats get updated. Now, my other option is, here we go, I could update my statistics manually. I'm specifying the name of the statistic here. Right, this is one of the column statistics that I created. And I'm going to check all of these again. And now I can see that this statistic has been updated. Great. And I've already checked that. Now, one of the things that I could do is when I did this original update, I just said update. I didn't specify a sample size. I can do that. I can update statistics with sample 10%. And right now, if you look at this, right, you'll see that it's a whopping 435 rows, and it's 100% sample. So what happens if I update with 10%? Let's take a look just at the statistic. It's still updated with 100%. And that's because this table is so small. It's less than 8 MB. So even if I'm specifying a smaller percentage, because this table is so small, it's ignoring basically that command. Let's try a larger table. I have the DBO batting table. Let's take a look at that. This one has 96,000 rows in it, and it sampled 79,000. So let's go ahead and sample this with 10%, and then look at the statistics again. Our sample size did go down, but it's still not even 10%. It's more than 10%, right? So this is only going to work over a certain size. And when it comes to what sample should you use, I get that question a lot. It's going to depend upon the characteristics of the data. Meaning, for some tables, let's think of something like an ID. Let's think of an ID that's an identity, right? So every time a row gets inserted into a table, it gets an ID, and you have a statistic on that ID. That ID is unique. And so whether I sample that at 100% or at 10%, the optimizer is actually going to have pretty similar information because of that data distribution in the column. But if I have a column like last name, where it's not unique, the data distribution there is random, and sampling at 10% could give me a very different set of statistics information than at 100%. It depends on your data, and it's a little bit beyond what I want to talk about today. But if you have questions, I can definitely give you some more guidance on that with some posts, so you can email me separately. Okay, let's go back. I want to talk a little bit more about the auto update option. So what I'm going to do first is I'm going to free procedure cache, which you never should do in your production environment because this removes all the plans from cache. But this is just for fun, so it's okay. I'm going to include my actual execution plan, and I'm going to make sure that auto update is on. Now, I'm going to make sure that I don't have any statistics here for this statistic. I don't have any information, right? Nothing exists. But I've got rows in the table, right? We know that I've got 12,000 rows or so in the table. So now I'm going to run a query. I'm going to query to see how many players do I have with the birth state of Michigan. And I've got 308. So now I'm going to look at my statistics again. And what happened is that they just updated. So because the amount of data in the column had changed, right, it invalidated the statistics. And so the next time that I went to query that data, SQL Server said, oh, this information is no longer valid. I'm going to update it. And it updated it because my auto update statistics option was enabled. Okay, and because this is a pretty small table, it updated it with 100% sample. And this goes into my question, which a common next question, which is, how does the engine know when statistics are out of date? How does it know when it needs to update them? Well, it tracks that information. And you can actually get some sense of that using DMDB stats properties, that DMV that I showed you earlier. So I can look at this, and I can say, okay, for my player info table, right, these are the different statistics that I have. These are the number of rows and the number of rows sampled. And this is the number of row modifications. Right? This is the number of changes that have occurred. So what I'm going to do is I'm going to run an update that's going to use this particular index. And I'm going to prove to you that it's going to use this index because I'm going to include some trace flags. Now, these are advanced trace flags that I would never run in production. And I've got a link to this nice article by Paul White about using them. But we're going to update player info. We're going to set first name to Theodore, where the first name is Ted and the last name is Lion. So we're going to go ahead and update this. And look at what I get in the output here. This is just kind of fun. Again, fun to play with, not fun to necessarily run in production. I can see that my non-clustered index is being used here. It's being loaded into memory for use by the optimizer, and it is right here, this index ID of 2. It's also loading, you can see, index ID of 5, which is a column level statistic that it created on first name because we don't have an index on first name. All right, now let's load in some more data. I'm going to load in everything that was above 12,000, so everything else in the table. So this is 4,500 rows. Now, if I look at my stats information again, now I have row modifications of 4574, right? Because I added all of those rows, and so all the columns in these statistics have changed. Now what happens if I run our update again for a different person? Now I'm going to update Ted Williams. His real first name was Theodore, so I'm going to update him in the database so that it says Theodore. So I'm running the exact same query again. And it loaded the statistics, right? I can see this. It's got index IDs too. And now let's check my statistics one more time. And if we look here for our non-clustered index, I can see that this statistic just updated, and now the number of row modifications is set to 0. And this is fun because this is my column level statistic on first name, and it's got the 1 row modification because I just changed Ted to Theodore. Okay, now let me pause for 1 second and see where I am. So the question is, when should we use the auto update asynchronous? I'm going to come in here and look at these options again just to make sure we're all on the same page. Okay, so we've got auto create enabled by default, auto update enabled by default, auto update asynchronously, set to false by default. So when I had this query just now, right, I added 4,000 rows to the table, and then I ran an update statement again, and because my statistics had been invalidated, when I ran this update the second time, it updated statistics for this non-clustered index. And it did that immediately. Now, if I would have had the async option enabled, it would have ran the query, and then it would have updated statistics after. So think through this here. If I leave it as the default, so statistics are invalidated, I run a query. The optimizer says, hey, these statistics are invalid. We need to update them. I'm going to update them right now. So we update them right now. What do we have to do? We have to wait. My query has to wait while those statistics are updated. Now, depending on how big your table is, how fast the system is, what else is going on, this may take a long time. It may not. In my case, it definitely didn't. But I have a little small database on a big, beefy machine. So this isn't a real-world example. Most of the time, these probably update pretty quickly. And the benefit is that they update, and then that updated statistic immediately gets used to create a new query plan. Right? This is what we want. Statistics are invalid. I'm going to update them. I'm going to use them in my new plan. Great. The drawback is that you have to wait for stats to be updated. Now, if you find that that's a problem, if you find that queries are taking a long time because auto update stats is running, then what you can do is you can say update stats asynchronously. So that means if I have that enabled, a query comes in, stats are not invalidated already. SQL Server says, hey, these are invalid. Oh, but wait, you've got the async option on. So I'm going to run your query right now, but I'm going to run it with the plan that was already in cache. All right, I'm going to run it with the old statistics. And if there were no plan in cache, it would run it using the old statistics. And so in that case, you may get a fine plan, but if your data distribution has changed or something in your statistics has changed dramatically, you may not get a good plan. So your query will run, and it's going to get the plan and return the data, and then stats are going to update. So you kind of offloaded that update, but you may be running with a less than ideal plan. So it's a trade-off. I'm not going to say which one you need to do. It really depends upon your environment. Okay, how to troubleshoot if update stats takes a longer duration to complete. So one of the things that you can do is there are, let's see, if I have this. It's not going to find that file. Hang on 1 second. Bear with me. I have a script that talks a little bit about this. And if I can find it quickly, which is not happening. Yes, it is. What you can do is you have, hang on, I'm trying to find this. You can run Profiler, which if you're running 2008 R2 and below, there is a event within Profiler that will allow you to capture auto updates of statistics. And you can also do this in extended events. So if you're running 2012 and higher within extended events, if we did a new session, which comes up on my other screen, there we go, stats, and we go into events and we go into statistics, you have an auto stat. So this will tell you when they are updated. So this could be one way to track if they are running and if they are taking an excessive long time to complete. Let's see. A question was, after stats have been updated, I stated that the queries will recompile. So the first queries will be slow. I don't want to say that the first queries will be slow, but if the statistic invalidates the query, if the statistic updated, the query plan is invalidated, so when the query comes in again, a new plan has to be created. That usually occurs pretty quickly, right? But you could see a spike in CPU usage because a lot of plans are suddenly being regenerated. Yes, that's possible. The question, rebuilding, reorganize does not update stats. Does it require to update stats manually? Let's clarify. Rebuilding an index does update the statistic with 100% sample. It's a great side benefit of rebuild. Reorganizing does not update the statistic. So if you're rebuilding, for example, if you're using a maintenance plan, let's create a new one. If you're using a maintenance plan, let's fuel my toolbox, not that one. I don't think I want that either. Can you tell how often I don't create maintenance plans? How funny that I can't remember where this is. Isn't it the toolbox? No? I can't even remember where this is. And now, by the way, you guys are like, seriously, Erin, just leave this. And I'm like, no, because I can't remember where that little guy is. Where is my toolbar? Can someone tell me at my question where it is? I want the task list. Oh, you guys are great. How much do I love this? Task list. No, I don't want the task list. That doesn't tell me. Maintenance plan. Sub plan, that's not going to do anything. Use the wizard. Toolbox. I had to. There it is. I swear I had that before. You all saw me select that before, right? I'm going to go back and watch to make sure that I'm not crazy. I had this select. I swear. Okay. Here's my point. Rebuild index. Right? I come in here and I do my rebuild index. And let's go ahead and select my baseball database. Ta-da. And I'm going to do all tables and views, et cetera, et cetera. This only is going to update the statistics for my indexes. So what I might do is come here and add my update statistics task for my baseball data database. And then, which is where it gets fun, I have all existing statistics, column statistics only, and index statistics only. So what did I just do when I rebuilt my indexes? I updated all the index statistics. So I don't want to update all existing statistics again because I'm just going to go and make the system do more work. And so what I would do here is I would say column statistics only. And then you have a choice of whether you're going to do a full scan or whether you're going to sample by something else. Now, this is one way to set up this maintenance task, by the way. The other thing is if you use Ola Hologren's script, for example, he's got lots of options in there for how to update statistics. Again, beyond the scope of what I'm going to talk about today. Let's see, what else do I have? Oh, this is a great question. Are we able to roll back a new statistic if the plans are bad? You're not. Oracle has an interesting feature where you can back up statistics, or I can't remember actually what the right terminology is for it, but you can save off statistics and bring them back. You don't have that option in SQL Server. So if you update statistics and your plans get worse, you're going to have to figure out exactly what about that statistic isn't providing the right information to the optimizer, whether it's a sample, whether it has to do with the distribution of data. Good question. Let me see. Sorry, I'm reading questions. Okay, so I've got this question. This question is in here a couple times, so I'm going to address it, which is, if I have a large database, are you recognizing that async stats is enabled? It's going to depend. It's a trade-off, and you need to understand the trade-off, so I'm not going to tell you which one to do. The trade-off is that if you have it disabled, which it is by default, and stats are going to update when they're invalidated. So your ways around that are to keep your statistics fresh, keep them up to date. So I talked about this wonderful view here, which shows you your statistics and the row modifications. If you're running, and I understand this is a big if, but if you're running 2008 R2 SP1 or 2012 SP1, you can query this information, and you can look to see how many rows have been modified compared against the number of rows in the table. And you can decide when to selectively update statistics rather than relying on SQL Server. You still want to leave auto update enabled because you need a safety in there. But you, as a DBA, can affect when statistics are updated. Okay? Let's see. If I'm running update statistics on tables, does it create any blocking or locking? It does take a lock. It's not going to prevent you from querying the data, but there's I think it's a schema modification lock that it takes. That's a great question, and I will look at logging that in a little bit more detail. I want to do some testing with that. So yes, it's going to take a lock. The exact detail, I don't remember off the top of my head. It shouldn't prevent you from querying data. Let's see. Oh, here's something that I want to show you. I want to talk. Where am I on time? Oh, I'm running out. Always happens with me. Last thing I want to talk about here, SP update stats. This is run for the entire database. So we know, right, how many modifications we have here. This has 1 row modified. These have 4,000 rows modified. I'm going to turn off include actual execution plan. Now, if I gave you this information right here and I said, okay, what statistics do you think we should update? Right? For the clustered index, we've had 4,500 modifications. For the non-clustered, we have none. For this column level statistic, we've had 1. For this column statistic, we've had 4,500. For this one, we've had 4,500. Which one should we update? I would be okay if you said the clustered index and these 2 columns. But watch what SP update stats does. Actually, I should save this off. Save that off for fun. Let's look at this. Look at that. Row modifications are set to 0 because it updated all of the statistics where it was not 0. So this is the thing about SP update stats. It looks to see if 1 or more rows have been updated, and then it updates statistics. I don't love that, because if only 1 row has been updated, do I really want to spend the resources to update statistics? As a DBA, you can do a lot more targeted updates, and only when you actually need to do updates, just kind of like with fragmentation, right? You look to see how fragmented the index is, and then based on that, you either do a rebuild or reorg or nothing. You can do the same thing with statistics now with this new VMS. Do I really need to update statistics? Let's see. I've got, let me see what I want to go back to in my slide deck. I'm actually going to skip through some of, actually I want to talk about this really quickly. Right, what are statistics? I want to make sure that you leave not just with how they're created and how they're updated, but understanding what they are. And it's this last line right here that I really like, which is, it's the distribution of values for a set of data. So I tend to think of a histogram like this. Basically, I'm taking the histogram output from SQL Server, and I'm flipping it on its side for last name. right? And for the last name of Armstrong, we have this number of rows. And for the last name of Cooney, we have this number. And for the last name of Janeski, we have this number, right? This is what that histogram looks like. This is that distribution of data in your statistic. And this is the information that SQL Server then uses to generate a plan. And this is a statistic this is the histogram just kind of narrowed in on a particular range of values. So let's see. I'm going through a lot of things really quickly. I know you're going to get these slides, so you'll be able to go back and read through this. But as a DBA, these are my general recommendations. This is what I want to end with. My general recommendations of how you should manage statistics. The first is keep your auto update option enabled. It's a safety net. Think of it as a safety net. Because I want you to set up a job to manage statistics. I want you to be proactive here, whether you set up a maintenance plan or whether you use older scripts. You can create a custom job, and I talked about this a little bit, which is going to look at the rate of change, really, and the skew of data and decide maybe updates based on how much data has changed. You can let SQL Server tell you about these updates using extended events or using Profiler. And you're also getting information from physical stats and usage stats to determine what the volume of data is and how often updates are occurring. Here's the take-home message, right? There's no one answer. There's no perfect solution that I can give all of you because you all have very different environments. What you need to understand is the importance of statistics, and that what you really want to try and do is provide the optimizer with as current and accurate information as you can so that it makes good decisions. So I think that I've kind of hit my 1 o'clock time frame. And all of these questions, I'm pretty sure that Steve can send to me along with your information. And in some cases, I think these have generated some great ideas for blogs, and I'll do my best to answer them in emails if I can.
Erin, if you want to take a few more minutes, if you have some more questions you want to answer, if you see some you really want to bring up, there's a lot of them.
There is a lot, and it's trying to pick one that's gonna. Okay. So one question is, I'm going to have the slides and the scripts available. Steve's going to put those. Steve, you put those on the site, right?
Yes.
Okay, they'll be available to download from the site, and the database will be on our SQL Skills site, and I will make that. I'll share that link with Steve as well. I think I'm good, Steve. I think I ended on a good spot. So.
Okay.
Other than my little maintenance task issues, we had no technical issues today. Hooray!
That was. I was very happy about that.
Yep.
Well, I want to thank you for coming back and sharing this webinar with us after we missed out on it earlier. I'm really looking forward to going back and looking at the recording, which will be available in about a week, along with Erin's scripts and the PowerPoint presentation from our site, fundamentals.sqlpass.org. And you can also go to SQL Skills and get the database, which is a lot better than looking at AdventureWorks. I really appreciate that. To take care of the last little business, we awarded our $25 Amazon card to Hiram Patel, and we'll be getting that out to him. And be looking for our invitation for next month's presentation on February the 4th on a drill down of SQL 2014. Thanks again, Erin. I appreciate it.
Thank you for having me. Hope you all have a great day.